So when we talk about privacy preserving training, we actually don't want to have that kind of extreme approach. And instead, we want to have the same mathematical guarantees of, let's say, the model never learning your actual sensitive information, but not having to strip away so much information so that a model doesn't learn, right? So that's actually a very interesting mathematical kind of like minimax kind of constraint optimization problem. And Dynamo actually started out doing this in the form of differential privacy, right? So adding basically small amounts of different perturbations and noise to the training process, so that when the model is learning the information, it also basically kind of forgets the actual details. So you might think about this, in a class you were taking, let's say 10 years ago, around a class around intro to machine learning. You might understand and recall the gist of the learnings. You can still recall, how machine learning works at a fundamental level, but you might not understand all the details, like every single example use case that you were coding up, or the names of the variables, right? And so that's kind of the same kind of technology and research that we're applying to here with differential privacy. Is we apply some level of perturbation so that the model gets confused around the actual details, but understands the fundamental knowledge.